November 22, 1922. Gosport, Indiana. A child was born into a world that would soon be consumed by economic collapse and global war. Eugene Morrison Stoner entered life with nothing but his name. In a small farming town where most families struggled, through the Great Depression, nobody could have predicted that this boy who would never attend college, who would spend his early years installing aircraft parts in California factories, would one day design the most controversial and widely used military rifle in modern history. The pencil moved across paper as the young machinist sketched modifications to weapons he had never been formally trained to build. Working late nights in his Long Beach garage after shifts at Vega Aircraft Company, Stoner was trying to solve a problem that had frustrated military designers for decades. How could you create a rifle light enough for soldiers to carry through jungles and mountains, powerful enough to stop an enemy at 500 YD, yet reliable enough to function in the harshest conditions on Earth? According to every expert in the firearms industry, according to the United States Army Ordnance Corps, according to tradition stretching back to the American Civil War, the answer was simple. You could not. A truly lightweight automatic rifle was impossible. The physics did not allow it. The materials did not exist. Anyone who claimed otherwise was either a fool or a fraud. Stoner was neither. He was simply willing to question assumptions that everyone else accepted as truth. And that willingness would eventually arm millions of soldiers, reshape modern infantry tactics, and spark debates that continue to this day. The year was 1939. Eugene Stoner had just graduated from Long Beach Polytechnic High School. College was not an option. The Depression had destroyed his family's savings, leaving no money for university tuition. While his wealthier classmates headed to Stanford and Berkeley, the young man walked into Vega Aircraft Company and asked for work. They hired him to install armament on training aircraft. The job required precision, attention to detail, understanding of mechanical systems. It also provided something invaluable: access to aircraft-grade aluminum, a material most gun makers had never considered using for firearms. For generations, rifle makers had relied on wood and steel, heavy, dense traditional materials that could withstand the explosive forces of gunpowder and the shock of recoil. The young engineer looked at these materials and saw limitations. Steel was strong but heavy. Wood absorbed moisture and warped. Both added unnecessary weight to weapons that soldiers had to carry for miles. But aluminum, the lightweight metal used in aircraft construction, offered different properties. It was lighter than steel, resistant to corrosion, and when properly engineered, strong enough to handle the stresses of rifle operation. The problem was that nobody had successfully built a combat rifle from aluminum. Every attempt had failed. Stoner filed that observation away. He would return to it later. December 7, 1941. Pearl Harbor. Like millions of young Americans, the 19-year-old enlisted in the military. He joined the United States Marine Corps, specializing in aviation ordnance. The Corps sent him to the South Pacific in northern China, where he spent his war maintaining and repairing machine guns, rifles, and automatic weapons. He never saw direct combat, but he saw something equally valuable for a future firearms designer. He saw weapons fail. He watched Marines struggle with the M1 Garand, a superb rifle that was nevertheless too heavy for jungle warfare. He observed the M1918 Browning automatic rifle, powerful but weighing nearly 20 delibo. He studied the M1941 Johnson rifle and light machine gun, innovative designs that most military planners dismissed as too complex. Every evening after his maintenance duties were complete, the young Marine sketched improvements. He filled notebooks with modifications, alternative gas systems, different bolt designs. His fellow Marines thought he was obsessed. They were correct. By 1943, he had developed two .30 caliber carbine prototypes in his spare time. Neither was complete, but both demonstrated concepts that would later appear in his revolutionary designs. The straight-line stock that channeled recoil backward instead of upward, the simplified gas system that eliminated heavy operating rods, the modular construction that allowed rapid field stripping. These were not random innovations. They were systematic solutions to problems the designer had observed in combat weapons. The war ended in August 1945. The 22-year-old veteran returned to California and immediately sought work in machine shops. He was hired by Whitaker, an aircraft parts manufacturer, starting on the factory floor. Within months, his skill with precision machinery earned him promotion to design engineer. It was here, working with aerospace manufacturing techniques, that he perfected his understanding of how to machine aircraft-grade aluminum to tolerances that would be acceptable for firearms. The knowledge would prove critical. By 1954, nearly a decade had passed, working various engineering jobs while continuing to design firearms in his garage. His prototypes had attracted attention from firearms experts, but no manufacturer was willing to invest in production. Then came an opportunity that would change everything. A small company called Armalite, a division of Fairchild Engine and Airplane Corporation, was looking for a chief design engineer. Armalite had been founded specifically to bring modern materials and manufacturing techniques to the firearms industry. They had fewer than a dozen employees. They had no factory. They were essentially a research and development operation, hoping to license their designs to larger manufacturers. It was perfect for the self-taught engineer. He was hired on October 4, 1954, and immediately set to work on his most ambitious project yet. The United States Army had announced in 1955 that they were seeking a replacement for the M1 Garand rifle. The new weapon needed to fire the standard NATO 7.62 mm cartridge, the same round used by most Allied nations. It needed to be reliable, accurate, and, if possible, lighter than the 912 LB Garand. Every major firearms manufacturer in America and Europe submitted designs. Springfield Armory offered the T-44, essentially an updated M1 Garand chambered for the new cartridge. Fabric National of Belgium submitted their FAL rifle already in service, with several European armies. Both were conventional designs: steel, receivers, wooden stocks, gas piston systems proven over decades of use. Both weighed around 9 lb. The Armalite submission was designated AR-10, Armalite Rifle Number 10. It weighed 7.25 lb. The Army testing officials at Springfield Armory thought there had been a mistake in the specifications. No rifle firing full power NATO ammunition could weigh that little and still function reliably. They assumed the paperwork was incorrect. Then the rifle arrived for testing in late 1956. The AR-10 looked unlike any military rifle the testers had ever seen. The stock and handguard were made of fiberglass reinforced with foam materials borrowed from aircraft construction. The receiver was forged from 7.75 T6 aluminum alloy, the same material used in aircraft structural components. The rifle featured a straight-line design with the stock aligned directly behind the barrel, rather than dropping below it as in traditional rifles. This meant recoil forces pushed straight back into the shooter's shoulder, rather than causing the muzzle to climb. The gas system was revolutionary. Instead of using a heavy operating rod like the M1 Garand, or a piston system like the FL, the design routed expanding gases directly from the barrel through a tube to the bolt carrier. This system, commonly called direct impingement, though technically an internal expanding gas system, eliminated nearly 2 lb of reciprocating metal. The initial testing reports were enthusiastic. Testers noted that the AR-10 was the easiest rifle to control an automatic fire that they had ever tested. The straight-line design combined with an effective muzzle brake made the rifle remarkably controllable despite firing powerful NATO ammunition. Accuracy was excellent. The rifle consistently produced groups under 2 and at 100 YD, better than either the T-44 or the FAL. Reliability was good in initial trials. The aluminum receiver showed no signs of stress or failure. Then came the endurance testing. The Army subjected the AR-10 to torture tests designed to reveal any weaknesses. They fired thousands of rounds through the rifle without cleaning or maintenance. They subjected it to extreme temperature variations. They dunked it in mud and sand. And during one particular test, the composite barrel, a steel liner surrounded by an aluminum sleeve, failed catastrophically. The barrel burst. The rifle was destroyed. The Army testing officials wrote their report. The AR-10 was rejected. They acknowledged its innovative features, its lightweight, its controllability, but they concluded that it would take 5 years or more to work out the problems and bring it to adoption. The United States Army selected the T-44, which entered production as the M14 rifle in 1957. The AR-10 had failed, but the designer had learned something crucial from the failure. The composite barrel had been a mistake specified by Armalite's president over his objections to save weight. He immediately designed an all-steel barrel for the AR-10, too late for the American Army trials, but not too late for other potential customers. In 1957, Armalite licensed production of the AR-10 to Artillerie Enriingen, a Dutch arms manufacturer. Over the next few years, the Dutch company would produce fewer than 10,000 AR-10 rifles, selling them to Sudan, Portugal, and several other nations. Portuguese paratroopers who used the AR-10 in African colonial wars praised its accuracy and reliability. French Foreign Legion troops in Chad, who acquired a few through various channels, reported that it was one of the finest combat rifles they had ever used. The AR-10 worked. It had simply arrived too late and too unproven for conservative American military procurement officers who preferred traditional designs. While the AR-10 was being manufactured in the Netherlands, the Armalite engineer was already working on his next design. He had proven that a lightweight rifle could work with full-power ammunition, but a question was emerging in military circles. Did soldiers really need full-power cartridges? Studies from World War II and the Korean War showed that most infantry combat occurred at ranges under 300 WSDD. At those distances, a smaller, lighter cartridge could be just as effective as the heavy NATO round, and soldiers could carry far more ammunition. The United States Continental Army Command issued new requirements in early 1957. They wanted a lightweight rifle firing a small caliber, high-velocity cartridge. The solution was to scale down the AR-10 design. The straight-line configuration, the gas system, the aluminum receiver, the modular construction all remained, but everything was sized for a much smaller cartridge, the 223 Remington. This sporting cartridge, originally designed for varmint hunting, fired a tiny bullet weighing less than 60 grains at velocities exceeding 3,000 ft/s. The high velocity meant the small bullet could produce devastating wounds despite its lightweight. The small cartridge meant a soldier could carry 300 rounds instead of 140 rounds of NATO ammunition. The first AR-15 prototype was completed in May 1957. When loaded with a 20-round magazine, the rifle weighed just 6 lb, less than half the weight of the M14. It was 39 in long compared to the M14's 44 in. It could fire in both semi-automatic and fully automatic modes. Early tests showed it could penetrate a steel helmet at 500 WSDD and a standard infantry flak jacket at 300 WSDD. The wound ballistics were exceptional. The small, fast-moving bullet would yaw and fragment upon hitting tissue, creating wounds far larger than the bullet's diameter. The United States Army tested the AR-15 and dismissed it. They had just adopted the M14. They were not interested in another rifle, particularly one firing what they considered a varmint cartridge. The Ordnance Corps, the branch responsible for weapons procurement, actively opposed the new design. Some historians suggest the opposition was personal. Armalite had rejected an offer from the Ordnance Corps to acquire development rights to the AR-10, fearing the Army would bury the design. The Ordnance Corps had not forgotten. They had invested their reputation in the M14. They were not going to admit they had chosen the wrong rifle. Armalite tried to market the AR-15 to foreign militaries. Some expressed interest, but United States foreign aid policy required allied nations to use weapons compatible with American military arms. Since the AR-15 fired a different cartridge than the M14, potential foreign customers could not purchase it. By 1959, Armalite was facing financial problems. They had spent years developing the AR-10 and AR-15, but had sold very few rifles. The company had no manufacturing capability and relied entirely on licensing fees. Fairchild Engine and Airplane Corporation, Armalite's parent company, decided to cut their losses. In February 1959, Armalite sold the rights to the AR-15 to Colt's Manufacturing Company for $75,000 plus royalties on each rifle produced. It appeared that the revolutionary rifle would join thousands of other firearms designs that showed promise but never reached production. Colt had purchased the rights, but they had no military buyer. The Army did not want the rifle. No foreign military could purchase it. The AR-15 seemed destined for obscurity. Then came a 4th of July barbecue that would change everything. July 4, 1960, a farm in Maryland. Richard Boutelle, president of Fairchild Corporation and former president of Armalite, was hosting an Independence Day party. Among the guests was General Curtis Lame, Vice Chief of Staff of the United States Air Force. Lame was a legend in American military circles. He had planned the firebombing campaign against Japan in World War II. He had commanded Strategic Air Command, building it into the most powerful military force in history. He was known for his demanding personality, his contempt for bureaucracy, and his willingness to fight for what he believed was right. At age 53, he was the youngest four-star general in American history. William Mullen, a cult salesman, had brought an AR-15 to the party, hoping for an opportunity to demonstrate the rifle to any military officers who might attend. When he learned that General LeMay would be present, Mullen prepared a demonstration. He placed watermelons at 50 yards and 150 yards downrange. He handed the AR-15 and several magazines to General LeMay. The general, an experienced shooter, examined the rifle briefly and then opened fire. The watermelons exploded. The tiny .223 bullets traveling at over 3,000 ft/s struck the watermelons and caused them to burst dramatically. Lame fired several magazines, hitting targets at various distances. The rifle functioned perfectly. When Mullen mentioned there was one watermelon remaining, Lame declined to shoot it. "Let us eat the son of a bitch," he said. The demonstration continued while the general and other party guests ate the surviving watermelon. Lame asked detailed questions about the rifle's design, its ammunition, its production capabilities. He learned that it weighed 6 lb when loaded compared to the 912 lb M14. He learned that an average soldier could carry 240 rounds of 5.56 ammunition compared to 100 rounds of 7.62 mm. Learned that marksmanship tests had shown 43% of AR-15 shooters qualified as expert compared to only 22% of M14 shooters. By the end of the party, General Curtis LeMay had made a decision. He wanted this rifle for the Air Force. Air Force security personnel still carried the M1 carbine from World War II, a weapon inadequate for protecting air bases against potential enemy attacks. The AR-15 would give them firepower comparable to infantry rifles while remaining light enough for security troops who needed mobility. Lame placed an order for 8,500 rifles and 8.5 million rounds of ammunition on the spot, at a 4th of July barbecue based on shooting watermelons. There was a problem. The United States Army controlled all rifle procurement for all branches of the military. For the Air Force to receive AR-15s, the Army would have to approve the purchase. The Army had already rejected the AR-15. They were not inclined to reverse that decision, particularly not because an Air Force general wanted the rifle. General Maxwell Taylor, chairman of the Joint Chiefs of Staff, advised President John F. Kennedy that having two different rifle calibers in the military system would be problematic. Lame's request was denied. Curtis LeMay did not accept defeat easily. Over the next 2 years, he would wage one of the most persistent campaigns in American military procurement history. The Air Force Vice Chief of Staff filed formal requests. He attended meetings at the Pentagon. He provided data from Air Force testing, showing the AR-15 superiority over the M14. He made it clear that the Army's objections were based on institutional pride rather than objective evaluation. In summer 1961, Lame was promoted to Air Force Chief of Staff, the service's highest-ranking officer. From this position, he had direct access to President Kennedy and Secretary of Defense Robert McNamara. He immediately requested approval for 80,000 AR-15s to equip the entire Air Force. Once again, the request was denied. The general was legendary for his unwillingness to quit. He filed a second request. He filed a third request. Each time, Army officials blocked the procurement, arguing that the M14 was superior and that having two different calibers in the military system would create logistical problems. Lame countered by pointing out that the Air Force already used different weapons than the Army in many categories. The debate dragged on through 1961 and into 1962. Meanwhile, events in Southeast Asia were creating pressure for a better infantry weapon. American military advisors in South Vietnam were reporting that the Viet Cong armed with Soviet AK-47 rifles were outgunning South Vietnamese troops armed with M1 Garands. The AK-47 fired an intermediate cartridge similar in concept to the AR-15's 5.56 mm round. It was lighter than NATO rifles, easier to control in automatic fire, and deadly effective in jungle warfare. American advisors began requesting AR-15s for field testing. In late 1961, Secretary of Defense Robert McNamara authorized a small-scale trial. 1,000 AR-15s were sent to Vietnam for evaluation by Special Forces units and South Vietnamese forces. The reports came back enthusiastic. Special Forces soldiers reported that the AR-15 was ideal for jungle combat. It was light enough to carry through thick vegetation. It was short enough to handle in close quarters. The small cartridge allowed soldiers to carry enough ammunition for extended patrols, and despite its small size, the rifle was devastatingly effective against enemy troops. The high-velocity lightweight bullets were producing severe wounds. South Vietnamese troops who received AR-15s for testing refused to give them back. They reported that the rifle's lightweight and controllability made it far superior to their existing weapons. Some Vietnamese soldiers said the AR-15 made them feel like they had the firepower of 3 men. Secretary of Defense Robert McNamara was now receiving two completely contradictory views. The Army insisted the M14 was superior, and the AR-15 was inadequate for military service. The Air Force, Special Forces, and Vietnamese field reports insisted the AR-15 was dramatically better. McNamara ordered additional testing. In early 1962, he established a new study to directly compare the AR-15, the M14, and the Soviet AK-47. The study known as the Hitch Report was released in summer 1962. The conclusion was devastating for the Army. The AR-15 was superior to the M14 in every measurable category. Soldiers armed with AR-15s could carry more ammunition, hit targets more reliably, and maintain their weapons more easily than soldiers armed with M14s. The study went further. It concluded that the M14 had failed to outperform even the AK-47, America's newest rifle, adopted just 5 years earlier at enormous cost, was inferior to the Soviet weapon it was supposed to defeat. The Army fought back. They claimed the tests were biased. They conducted their own evaluations showing the M14's superiority. They argued that the 5.56mm cartridge lacked stopping power. But McNamara had made his decision. In November 1962, he approved initial procurement of AR-15 for the Air Force and Army Special Forces. General LeMay finally received approval for his rifles, though not the full 80,000 he had requested. His persistence had paid off. The first shipments of 8,500 rifles arrived in May 1962, nearly 2 years after his initial order at the Maryland barbecue. The rifle was now designated the M16. Colt had made several modifications to the original AR-15 design, most notably moving the charging handle from under the carrying handle to the rear of the receiver. Production began ramping up. In November 1963, McNamara ordered 104,000 rifles, 85,000 XM16E1s for the Army and Marines, 19,000 M16 for the Air Force. The contract worth $13.5 million was awarded to Colt on November 4, 1963. By late 1963, tens of thousands of M16s were being manufactured, and in early 1964, the first large shipments began arriving in Vietnam. The Army, still skeptical of the new rifle, began replacing M14 with M16 in units deploying to Vietnam. The impossible had become reality. A lightweight rifle firing a small cartridge was replacing the traditional heavy rifle that military planners had insisted was necessary. Everything seemed perfect. The M16 was lighter, easier to shoot, more controllable in automatic fire. Soldiers could carry twice as much ammunition. The rifle had performed flawlessly in all official testing. And then the soldiers in Vietnam started dying because their rifles were jamming. The reports began arriving in late 1965. M16 were malfunctioning in combat. The rifles were failing to extract spent cartridge cases, leaving them stuck in the chamber. Soldiers were found dead. Their rifles disassembled beside them, desperately trying to clear jams while under enemy fire. Marines wrote letters home describing their rifles as pieces of junk. Some soldiers were so distrustful of the M16 that they picked up enemy AK-47s from the battlefield, risking court-martial to carry a rifle they could trust. Parents received letters from their sons describing rifles that jammed every few rounds. One Marine wrote home, "We left with 72 men in our platoon and came back with 19. Believe it or not, you know what killed most of us? Our own rifle. Practically every one of our dead was found with his M16 torn down next to him, where he had been trying to fix it. The malfunction rate was staggering. In one survey conducted in 1967, 80% of 1,585 troops reported experiencing stoppages while firing. The M16, the rifle that was supposed to give American soldiers an advantage over the enemy, had become a liability. Soldiers began calling it the Mattel toy after the plastic toy company. They said it was fine for shooting at targets but failed when lives were on the line. Some units requested to be re-equipped with the old M14. Others scavenged AK-47s from dead Viet Cong. An underground market developed where soldiers traded cigarettes and other goods for captured Soviet rifles. The weapon that was supposed to represent American technological superiority had become a symbol of betrayal. What had gone wrong? How had a rifle that performed flawlessly in testing become fatally unreliable in combat? Eugene Stoner was stunned by the reports. He flew to Vietnam in early 1967 to investigate personally. What he discovered would eventually trigger a congressional investigation and expose one of the most shameful episodes in American military procurement history. The rifle he had designed was fundamentally sound, but the Army had changed it, and those changes made without proper testing, without consulting the designer, without understanding the engineering principles behind the rifle's operation, had turned a reliable weapon into a death trap. The first problem was the gunpowder. Stoner had designed the AR-15 to use IMR 4475 powder, a specific type of stick powder that burned relatively cleanly. This powder had been used in all testing of the rifle. It produced consistent pressures, left minimal residue, and the rifle functioned reliably with it. But the Army, without consulting Colt or the designer, switched to a different propellant. They changed to WC-846 ball powder, manufactured by Olin Matt, which had close relationships with Army procurement officers. Ball powder burned dirtier than IMR powder. It left more residue in the chamber and on the bolt. It also produced slightly higher pressures, which increased the rifle's cyclic rate of fire from approximately 750 rounds per minute to nearly 1,000 rounds per minute. The higher cyclic rate meant the rifle's extraction system was pulling cartridge cases out of the chamber faster than intended. Combined with the dirtier powder, leaving more residue in the chamber, this created the perfect conditions for extraction failures. Spent cartridge cases would stick in the chamber, and when the bolt tried to extract them at high speed, the case rims would tear off, leaving the case stuck in the chamber. The only way to clear the jam was to push a cleaning rod down the barrel and knock the case out, a procedure that was impossible during a firefight. The second problem was chrome plating, or rather the lack of it. The designer had specified that the chamber and bore should be chrome plated to prevent corrosion. Chrome plating was standard practice for military rifles that would be used in humid environments. The humid jungles of Vietnam, with their constant moisture and lack of proper cleaning facilities, were exactly the conditions where chrome plating was essential. Armalite had recommended chrome plating from the beginning. Colt had specifically requested chrome plating in their communications with Army procurement officers, but the Army, seeking to save money, deleted the chrome plating specification. They claimed it was unnecessary. The steel chambers corroded quickly in Vietnam's humidity. Corroded chambers increased friction during extraction, making the cartridge case sticking problem even worse. Ammunition stored in humid conditions also corroded, with the brass cartridge cases developing a patina that increased friction. In later testimony to Congress, experts would identify the lack of chrome plating as the single most critical cause of M16 failures in Vietnam. The third problem was maintenance training, or rather the complete absence of it. The Army had decided to advertise the M16 as self-cleaning. They told soldiers that the rifle did not need regular maintenance. Cleaning kits were not issued to troops. Technical manuals were not distributed. Soldiers arrived in Vietnam having fired the M16 once or twice for familiarization, with no training on how to maintain it, and without the tools to clean it, even if they had known how. The rifle was not self-cleaning. No firearm is self-cleaning. The gas system, which routed hot gases directly into the receiver, required regular cleaning to prevent carbon buildup. Combined with the dirty ball powder, lack of chrome plating, and humid environment, the lack of maintenance meant rifles quickly became so fouled they could not function. Soldiers who had spent years maintaining M1 Garands and M14, weapons that could function with minimal maintenance, found themselves carrying rifles that required constant attention just to keep running. One particularly tragic incident documented by the congressional investigation involved a Marine unit engaged in heavy combat. Only one Marine in the squad had a cleaning rod, As his fellow Marines' rifles jammed one by one, this Marine ran up and down the line using his cleaning rod to clear each jammed weapon. He was killed while trying to clear a jam for another Marine. The investigation concluded that he died because the Army had failed to issue cleaning equipment to the troops. The fourth problem was the forward assist. The original AR-15 design did not have a forward assist, a device that allowed the shooter to manually push the bolt forward if it did not close completely. The designer had deliberately omitted this feature. His design philosophy held that if the bolt did not close on its own, there was a problem that needed to be fixed, not forced. But Army ordnance officers, accustomed to rifles with forward assists, insisted on adding one to the M16. The forward assist allowed soldiers to force rounds into dirty chambers, creating even more pressure on the extraction system and making jams more likely. Tests conducted at Rock Island Arsenal had shown that forcing the bolt forward could cause serious extraction failures, but the Army ignored these findings. By early 1967, the M16 disaster had become a national scandal. Parents were writing to congressmen. Newspapers were running stories about defective rifles. Soldiers were dying not because of enemy action, but because their weapons had failed them. On May 15, 1967, Representative Richard the Sixth Court of Missouri convened a special subcommittee on the M16 rifle program. The hearings would continue through August 22, 1967, calling hundreds of witnesses and producing a report that remains one of the most damning documents in American military history. Eugene Stoner testified before the subcommittee. He explained that the Army had changed his design without consulting him. He demonstrated that with IMR powder, proper chrome plating, and adequate maintenance, the M16 was as reliable as any military rifle ever produced. He brought documentation showing that he had recommended chrome plating from the beginning. He presented test data, proving that the rifle functioned perfectly with the correct ammunition. Cult representatives testified that they had warned the Army about the problems with ball powder, but had been ignored. They presented documentation showing that Colt had specifically recommended chrome plating, but the specification had been deleted to save money. They described how Army procurement officers had pressured them to accept changes that Colt's engineers knew would cause problems. Internal Colt memoranda to the committee showed that the company had predicted the extraction failures months before they occurred in Vietnam. Army ordnance officers testified, and their testimony was devastating. Under questioning, they admitted they had not properly tested the ball powder before approving it for use. They acknowledged that they had not issued cleaning kits or training materials to soldiers in Vietnam. They confirmed that they had advertised the rifle as self-cleaning, despite having no evidence to support that claim. Some officers admitted they had personally opposed the M16 and preferred the M14. The subcommittee's report, released on October 19, 1967, ran to nearly 600 pages. The conclusion was damning. The report stated that the M16 malfunctions were caused by Army mismanagement and neglect. The Ordnance Corps had changed the rifle's ammunition without proper testing. They had deleted essential specifications like chrome plating to save money. They had failed to provide training and maintenance equipment to soldiers. They had ignored warnings from the rifle's designers and manufacturer. The report used language rarely seen in congressional documents, stating that the failure to take corrective action bordered on criminal negligence. The scandal forced immediate action. The Army rushed chrome-plated chambers and bores into production. They switched back to improved powder for M16 ammunition. They manufactured millions of cleaning kits and distributed them to every soldier in Vietnam. They developed a comic book-style manual explaining how to maintain the rifle. They instituted mandatory training programs on M16 maintenance. They made 10 modifications to the rifle design, creating the M16A1. The modified rifle was officially standardized on February 28, 1967, replacing the earlier XM16E1 designation. The M16A1 with chrome-plated chamber, proper ammunition, cleaning equipment, and trained soldiers proved as reliable as the designer had always claimed it would be. By late 1968, the malfunction rate had dropped to levels comparable to any military rifle. Soldiers who received the updated M16A1 along with proper training and cleaning equipment found it to be an excellent weapon. It was light, accurate, controllable, and when properly maintained with the correct ammunition, completely reliable. The rifle began to earn respect on the battlefield. Soldiers appreciated that they could carry 300 rounds compared to 140 rounds of M14 ammunition. They found the rifle easy to handle in the close-quarters combat common in Vietnam. They discovered that the small high-velocity bullet was devastatingly effective against enemy troops. The M16A1 continued in service through the remainder of the Vietnam War and became the standard rifle for all United States military branches. By the 1970s, it had been adopted by dozens of allied nations. By the 1980s, millions had been produced. The rifle continued to evolve. The M16A2, introduced in the 1980s, featured a heavier barrel, improved rear sights, and a brass deflector to protect left-handed shooters. The M16A4, introduced in the 1990s, added a flat-top receiver with a Picatinny rail for mounting optics. In 1994, the military introduced the M4 carbine, a shortened version with a 14.12 in barrel and collapsible stock. The M4 would eventually replace the M16 in most frontline units, becoming the standard infantry weapon. But both weapons shared the original design principles: the gas system, the straight-line stock, the aluminum receiver, the modular construction. The innovations conceived in a Long Beach garage in the 1950s remained the foundation of America's military rifles 70 years later. Eugene Stoner did not stop with the AR-15. In 1961, after Armalite sold the rights to Colt, he left to work as a consultant for Colt. He then moved to Cadillac Gauge, where between 1962 and 1963, he designed the Stoner 63 weapon system, a modular design that could be configured as a rifle, carbine, or light machine gun. The Stoner 63 was adopted by the United States Navy SEALs and saw limited use in Vietnam. Approximately 4,000 units were manufactured between 1963 and 1971. The weapon demonstrated the designer's continuing innovation, though it never achieved the widespread adoption of the M16. In 1971, he co-founded Ares Incorporated in Port Clinton, Ohio. At Ares, he developed improved versions of the Stoner 63, designated the Stoner 86. He also worked on advanced concepts that were decades ahead of their time. He experimented with polymer ammunition, attempting to reduce weight even further. He developed telescoping cartridges that would allow more rounds to fit in a magazine. He worked on caseless ammunition systems. These concepts, considered too radical in the 1970s, would later influence rifle development in the 21st century. In 1990, at age 67, Eugene Stoner joined Knight's Armament Company in Titusville, Florida. There he designed the SR-25, a scaled-up version of the AR-15 chambered for 7.62 mm NATO ammunition. The SR-25 combined the accuracy of a precision rifle with the reliability and handling characteristics of the M16. It was adopted by the United States Navy as the Mark 11 Mode 0 sniper weapon system. Navy SEALs would use the rifle in Iraq and Afghanistan, praising its accuracy and reliability. It was one of the designer's final creations and one of his finest. The SR-25 proved that the basic AR-15 design could be successfully scaled for larger cartridges, validating concepts he had first explored with the AR-1040 years earlier. In May 1990, Eugene Stoner met Mikhail Kalashnikov, designer of the AK-47, for the first time. The two legendary firearms designers, whose rifles had armed opposing sides in every major conflict since the 1960s, met in Washington. They toured the NRA's National Firearms Museum together, examining each other's designs displayed side by side. They went shooting at a range in Virginia, each firing the other's weapons. They visited the Marine Corps base at Quantico, where they witnessed testing of new weapons. By all accounts, they became friends over those few days. Two designers who understood that they had both been trying to solve the same problems, just from different philosophical approaches. Kalashnikov favored simplicity and ruggedness above all else. Stoner favored lightweight and precision. Both had succeeded in creating weapons that would serve their nations for generations. Eugene Morrison Stoner died of cancer on April 24, 1997, at age 74. He was working on a firearms design in his garage in Florida when he became too ill to continue. He was buried at Quantico National Cemetery in Virginia, among the Marines he had served with more than half a century earlier. He was survived by his wife Barbara, whom he had married in 1965, 4 children from his first marriage, 7 grandchildren, and 4 great-grandchildren. He left no significant estate. Despite designing the most widely produced military rifle in American history, he had never grown wealthy. The licensing agreements that brought him royalties were modest, and he had spent his life working for companies rather than owning them. He died as he had lived, quietly working on the problems that fascinated him, avoiding publicity, letting his designs speak for themselves. The rifle he designed has become the most controversial firearm in American history. More than 30 million AR-15s, the civilian semi-automatic version of the M16, are now in American homes. They have become the symbol of gun rights for some Americans, and the symbol of gun violence for others. 10 states have enacted varying degrees of restrictions or bans on AR-15-style rifles. The debates continue, passionate and unresolved. His family has stated publicly that he designed the AR-15 as a military weapon, not for civilian use. They believe he would have been horrified by the weapon's association with mass shootings. Others argue that he would have supported civilian ownership of his design, pointing to his work on civilian firearms throughout his career. The truth, like many things about the man, is probably more nuanced than either side acknowledges. What is beyond debate is the rifle's military significance. The M16 family of rifles has served in every American military conflict since Vietnam. It has armed American soldiers in Grenada, Panama, the Persian Gulf War, Somalia, Bosnia, Kosovo, Afghanistan, and Iraq. It has been adopted by more than 80 nations. It has been manufactured under license by South Korea, Singapore, and the Philippines. It has inspired countless copies and derivatives. The Taiwanese T-65, the Canadian C-7, the British L-85A1, and dozens of other rifles trace their lineage directly to the original designs. The rifle changed modern infantry tactics fundamentally. Before its adoption, infantry combat doctrine assumed soldiers would engage enemies at ranges of 400 to 600 yards. The M16's intermediate cartridge was optimized for combat under 300 wide. This forced military planners to rethink how infantry units would fight. The result was new tactics emphasizing fire and maneuver, suppressive fire and rapid assault. Modern infantry combat, with its emphasis on speed and overwhelming firepower, was enabled by the M16's combination of lightweight and high rate of fire. The rifle also changed military logistics in ways that are often overlooked. Because 5.56mm ammunition was lighter than 7.62mm NATO rounds, soldiers could carry more ammunition for the same weight. This meant infantry units could sustain fire for longer periods without resupply in extended operations, far from supply bases. This was a critical advantage. The M16's lightweight combined with its ammunition efficiency made modern air assault tactics possible. Soldiers could be inserted by helicopter carrying enough ammunition for sustained combat, something that had been impossible with heavier weapons and their bulkier ammunition. The gas system pioneered in the design became the standard for modern military rifles. While some designers still prefer piston systems, most current military rifles use variants of the direct gas system. The system's simplicity, lightweight, and reliability when properly maintained have proven difficult to surpass. Even rifles that appear dramatically different often incorporate design principles first demonstrated in the AR-15. Eugene Stoner's story challenges many assumptions about firearms design and military procurement. He had no formal engineering education beyond high school. He learned his trade in aircraft factories and machine shops. He designed weapons in his garage, not in military laboratories. He questioned traditional wisdom that everyone else accepted as unchangeable. He succeeded because he was willing to think differently, to use materials that others dismissed, to challenge experts who insisted his ideas were impossible. The Army ordnance officers who opposed his rifle had decades of experience. They had engineering degrees from prestigious universities. They had designed weapon systems that had served in 2 world wars. They were convinced that a self-taught machinist from California could not possibly know more about rifle design than they did. They were wrong, and their arrogance, their unwillingness to admit they might be wrong, cost American soldiers their lives in the jungles of Vietnam. The M16 disaster of 1967 was not caused by flawed design. It was caused by military bureaucrats who changed the design without understanding it, who ignored warnings from the designer and manufacturer, who prioritized institutional pride over soldier safety. The congressional investigation concluded that officials with authority in the Army had failed to take action to correct known deficiencies, and that this failure bordered on criminal negligence. Yet despite this damning conclusion, no one was held accountable. No one was court-martialed. No one was relieved of command. The institutional culture that had created the disaster remained largely unchanged. The subsequent investigation and reforms improved military procurement procedures, but similar problems continue to emerge. The lesson that should have been learned, that innovation can come from unexpected sources and that expertise should be respected regardless of its origin, remains difficult for large institutions to accept. The M16's troubled introduction to service stands as a cautionary tale about the dangers of bureaucratic arrogance and the importance of listening to designers and engineers who actually understand the systems they create. Eugene Stoner never became famous in the way that Thomas Edison or Henry Ford became famous. Most Americans who own AR-15s do not know his name. Most soldiers who carried M16s in Vietnam never learned who designed the rifle that saved or took their lives. He remained throughout his life a quiet, modest engineer who was more comfortable in machine shops than in corporate offices. He avoided publicity. He rarely gave interviews. He let his designs speak for themselves. When reporters did manage to interview him, they found a soft-spoken man who was more interested in discussing technical details than receiving credit for his achievements. But his legacy is impossible to ignore. Walk into any American gun store and you will see dozens of AR-15 variants. Visit any military base and you will see soldiers training with M4s, direct descendants of his design. Look at infantry tactics manuals from any modern military and you will see doctrines that assume soldiers carry weapons with the characteristics built into the AR-15. His rifle became the standard against which all other infantry rifles are measured. When nations develop new military rifles, they compare them to the M16. When soldiers debate the merits of different weapons, the M16 is the baseline. The statistics tell the story of unprecedented success. Approximately 8 million M16 rifles have been produced for military use worldwide. The M4 carbine, a derivative of the M16, has been produced in additional millions. More than 30 million AR-15 rifles have been sold to American civilians, making it the most popular rifle platform in the United States. The rifle has been manufactured in more than a dozen nations. It has served in more than 100 conflicts. It has armed soldiers from more than 80 nations. It has been the primary weapon of the United States military for over 60 years, longer than any other rifle in American history, and it shows no signs of being replaced. The United States Army has conducted multiple programs seeking to replace the M16 and M4 with new rifles. All have concluded that no currently available design offers sufficient advantages to justify the enormous cost of switching to a new weapon system. The latest attempt, the Next Generation Squad Weapon Program, has produced a new rifle, but full replacement of the M4 will take decades if it occurs at all. The M4 will likely remain America's primary infantry rifle for years to come. Eugene Stoner proved that one person working with determination and intelligence can change the world. He proved that formal education is not required for innovation. He proved that questioning accepted wisdom can lead to breakthroughs that experts miss. He proved that lightweight materials and unconventional designs can succeed where traditional approaches fail. And he proved, though he did not live to see it fully realized, that good engineering will eventually overcome bureaucratic resistance and institutional inertia. The rifle they said could not be made became the rifle that defined modern infantry warfare. The machinist they dismissed as unqualified designed the weapon that experts still cannot improve upon. The young man who could not afford college created technology that changed military history. Eugene Morrison Stoner, born in a small Indiana town during an economic depression, died having accomplished what he set out to do. He designed and built the most effective infantry rifle the world had ever seen. That the journey from garage workshop to military standard required decades, congressional investigations, and countless obstacles only makes the achievement more remarkable. The rifle everyone said was impossible to make became, against all odds and all expectations, America's rifle.